Let's start it. In this session, uh, we are going to start Master AWS Lambda. Let's understand the AWS Lambda function. What are AWS Lambda functions? How it will work, and where we are going to use AWS Lambda functions, and what are key features of Lambda functions, pricing, pre-tier limits, then limitations of AWS Lambda. Okay, we are going to discuss all these concepts as a part of this one team. Uh, AWS Lambda functions overview or introduction. Okay, first let's start understanding AWS Lambda team. In AWS Cloud, we have 200 plus services. 200 plus services. In that, most popular service is AWS Lambda. Okay. AWS Lambda is one of the most popular service. What kind of implementations? What kind of implementations? So, what kind of applications we can develop using AWS Lambda? AWS Lambda can be used to develop two kinds of applications team. One, services, services like web services kind of thing. And second one, event driven applications. Event event driven applications. Event driven applications. Let me explain event driven. So in our AWS data engineering, we use AWS Lambda most of the time to implement event driven applications team. Example, let's say we have AWS S3. Let's say we have AWS S3. We have AWS S3. In this AWS S3, we created a bucket. In this bucket, let's say we created a folder. In this folder, we have partitions based on year and month and day. Let's say 2026 is year partition. In that month partition, let's say 01. In that day wise, let's say 0, 1, and so on, and so on, all the dates. For every date, we have partitions. Let's say today, let's say 5th Jan. So in 5th Jan, in 5th Jan, let's say 05, a file is created. A file is created. A file is created. Then it will generate event. It will generate event called put event. Put event. When file is generated, we want to trigger Lambda service. We want to call Lambda service. In this Lambda service, in this Lambda, we want to write basic checks. Let's say basic checks. First one, basic checks like, let's say we are expecting dot parquet. Expectation is dot parquet. We got dot CSV or dot JSON. Then we can generate a error saying uh, file loaded different file format or file format is different. We want to give a log message to the user or some our log admin people. We want to, or whoever monitoring, we want to intimate them we received different file format so that we are not processing ETL job. We are not calling ETL job. Let's say every ETL job executing when file is loaded. But file is different format. In ETL job, we are expecting dot parquet format. So if you call ETL job, it will fail, right? Yes or no? So before calling ETL job, we are validating, we are getting expected format file or not. Second check. Let's say if file is empty, then no need of doing ETL job, right? Then that check also we are doing in Lambda. So file size, we are checking file size. If file size is empty, no need of calling ETL job, then provide a message to the user. Log message saying we received empty file. That's why we are not calling ETL job. Next one. Let's say every day we are getting 10 files. Assume every day we are getting 10 files. 10 files. In that one file is very important file. To process this 9 file, we use this important file for comparison purpose. Comparison purpose. If this file is not available, then doing this ETL job is no use. So we are going to check that file is existed or created or not in today's partition. If that is not presented, then we can write a message to the team saying the file X is not generated, so that we are not calling ETL job. So basic ba- such kind of implementations right inside Lambda. So these are executing when event is generated. What event? File loaded event called put event. So that's why we are calling event driven applications. So these kind of implementations we can implement using AWS Lambda in our AWS data engineering. Along with this event driven, we can also develop services, web services kind of implementation using AWS Lambda. AWS Lambda, AWS Lambda, let me open Lambda, Lambda service, Lambda service. AWS Lambda supporting multiple programming languages. It's supporting .NET, it's supporting Java, it's supporting Node.js, it's supporting Python, it's supporting Ruby, and also you can attach a custom runtime environment. You can use a custom language to run your programming. Okay, most of the time we use either .NET, Java, Node.js, Python. In our implementation, we are going to implement AWS Lambda using Python programming language. Next one, let me open .NET. So AWS Lambda is a serverless compute service. First important point, it is a serverless compute. You just write your Lambda using any programming language you like it. Then you can run that Lambda. You can that run Lambda. That's it. You no need a separate mission, and you can say, I want these many resources. I want this much RAM. I want these many CPUs. Such kind of things you least bother about it. That is taken care by AWS Cloud. You can focus on implementing your application. Rest will taken care by AWS people. How it will work is we are going to write these applications by using AWS Lambda, or you can create applications locally, then you can convert to zip file and you can upload into container. So we can implement use cases like processing S3 bucket data and through REST service, through HTTP services like service calls. We can reply to that service calls. Then we can build event-driven applications. Key features too, very important. Key features are auto scaling, high available. So based on your input data, resources are going to scale automatically to process your request. You least bother about infrastructure. Second one, you no need to set up a server. It is a serverless execution. You focus on selecting a language. You focus on writing the implementation. Execution will taken care by AWS. And this is very important one. Pay for use price. See here, pricing, it comes with the free type, 1 million free requests and 4 lakh GB seconds of compute per month is free. After that, they are going to start generating bill. So pay per use pricing. It is supporting multiple programming languages. And you can use AWS Lambda to integrate different AWS services. And next one, by default, any service in AWS gets first level security using AWS IAM. Let's say we have 10 users. We do not want to give AWS Lambda access to 10 users. I want to give only X user to Lambda. For others users, I do not want. We can put a security access restrictions using AWS IAM policies on AWS Lambda. Okay. What are limitations of Lambda? Very important to him. So if you are putting experience in Lambda, you will get this question. What are limitations of Lambda? So if you are running more than 15 minutes, then your script automatically going to terminate. Maximum execution time is minutes. Let's say your script is taking more than 15 minutes. It will terminate. Next one, memory limit. Maximum allocation is 10 GB, 10 GB memory. You can process 10 GB of memory data. So if you want pure data processing, go with AWS Glue. If you remember, I said we can implement event-driven applications. There, we are just doing file type, file checking type, and file size, and particular file. So these are just processing, finding. It won't to take much storage. It won't to take much time to process. So such kind of implementations we can do with AWS Lambda. Also, we can use AWS Lambda for calling data pipelines. Let's say job one, first I want to call. Once that is completed, I want to call another job. Such kind of data pipeline we can define in AWS Lambda. Okay. So these are main purposes we use Lambda. If data is more, it is never recommended. Clear, right? What is AWS Lambda? Yeah. Now let's start understanding how to create AWS Lambda functions. AWS Lambda functions we can develop in multiple ways too. First one, using AWS Management Console. So you need AWS account and you can navigate AWS Lambda in search bar by typing Lambda in search bar. Then you can open Lambda. This is AWS Lambda Management Console or AWS Lambda base or AWS Lambda dashboard. So from AWS Management Console, in search bar, we can search Lambda. Then if you open Lambda, this is Lambda homepage or dashboard. Okay. Using this AWS Lambda dashboard, we can develop AWS Lambda applications. Second approach. Second approach is using AWS CLI. Using AWS CLI command, we can write Lambda functions, then we can submit Lambda functions, but this is complete command user interface. And other one, there is a approach called AWS SAM, serverless application model to implement Lambda applications. So in this, recommended one is this one thing. This is complete graphical approach. Graphical approach. You can see AWS Lambda dashboard. You can see different functions. If you want to create a function, you can click on. First, you need to select a language. Then you can click on create a function. Later also, you can select a language once you click on create a function. Okay. Yeah. Let's start it. As part of master AWS Lambda, we start writing AWS Lambda examples using Python programming language. Let's start the first writing first AWS Lambda example called hello world function. So first go to AWS Lambda, click on first go to AWS Management Console, navigate AWS Lambda service, then click on create function. Then here we need to choose author from scratch. Author from scratch. Then here you can give a function name. Hello world function. Then select a language runtime. I'm selecting Python 3.14. Then remaining options are optional. First one, give a function name, select a runtime environment. Okay. And later we are going to see other options. Right now, remaining options are default options. Then click on create a function. Now you can see, yeah, do not show this message. Click on dismiss. You can see code is generated. Let's wait few seconds. You are going to see code here. You can see code is generated. And let's start understanding this coding. Every AWS Lambda program contain one function name called lambda underscore handler. It takes one parameter is event, another parameter is context. First, let's discuss these two parameters are default parameters in lambda handler. You need to use these parameters in any lambda function development. Later, while implementing, we are going to use these two parameters. Okay, first one. Second point, function should be lambda underscore handler. Okay, next one, Tim. Next one. Here it is generated a default code. If this function is called, it is going to return a message from hello from lambda, or you can change a message hello from Akkem Sreenivas lambda. Okay. Then then first point first point lambda name should be this one. Second point, lambda takes these two default parameters. These two default parameters. Third one, inside this function, we can write a definition. And fourth one, once you complete this definition, you have to click this deploy code. Whatever changes you do inside this lambda underscore handler, once that changes are completed, you have to click on deploy. Okay, click on deploy. Click on deploy. Once change is completed, you can click on deploy. Then click on OK. Now, sorry, now you can see to run fifth step. To run your code, we have multiple ways. One way is test. Click on test. Click on test. You can see create a new test event. Then I am giving hello world, hello world test, hello world test. Then you can see parameters, event parameters. You can give anything. First function, you can give anything. Later, we are going to see how to pass parameters. Okay. Then click on save. Then click on invoke. Click on invoke. Invoke. See, you can see response, output. What is the response here? Hello from Akkem Sreenivas Lambda. It means your lambda is executed successfully without any. Clear writing? Yeah. Let's start him as part of Master AWS Lambda. In this session, we are see S3-based data ingestion and processing using AWS Lambda. So let me open my uh, drive with the data sets. In AWS Lambda, I have a file called orders.csv. Orders.csv. So this is my orders.csv. I am going to place this file into S3 location. Okay. Once we place file into S3 location, then I am going to use, let's hyphen Sreenivasa hyphen AWS or let's say S3. S3. In this location, let's say I am loading a file. File name is, let's say, orders.csv. See here, when file is loaded into incoming using AWS Lambda, I am going to process this file. I am going to write AWS Lambda logic to process this file. So when put event is generated, I want to call this Lambda function. I want to process this one. Data processing, I am to implement in AWS Lambda. So let's first start creating bucket in S3. So first log in AWS Cloud. I already logged in. Let's say here I am opening S3. In this S3, let's see. Here you can see buckets. Okay, I am creating one bucket. Create a bucket. Akkem Sreenivasa. Akkem Sreenivasa. Hyphen, let's say Lambda. Lambda bucket I am creating. Then uncheck this option. I acknowledge, create a bucket. Create a bucket. So I am creating bucket name Akkem Sreenivasa Lambda. Lambda. Okay, I created a bucket. In that I am going to create a folder called incoming. Okay, in this bucket I am creating a folder called incoming. So in this folder, later I am going to place a file, because when I place file, I want to invoke Lambda function. So I am going to create a Lambda function. Go here and open Lambda. In this Lambda, I want to create a Lambda function. Click on create a function. I am giving function name is S3 based data ingest. I am creating S3 based data ingest. Okay. Then I am selecting runtime is Python. Then click on create a function. See here, function name with invalid characters. Sorry. Here, no space till, no this. Then click on create a function. S3 based data ingest. Okay. Then inside this Lambda function, okay, go to the code, let's wait for generating the code, and after that we are going to modify with our actual code. This is the logic I am going to replace. I am going to replace this code too. I am going to replace this code. So I am importing I am importing some libraries like JSON, Boto3, CSV, input output uh, libraries. Then for Lambda function, this is our Lambda function, and we have a file in S3. We have a file in S3. So to create a connection between Lambda to S3, we are using Boto3 API. Boto3 API. Then one important function called def lambda underscore handler. Inside our Lambda program, function name should be lambda underscore handler. Here, two parameters. One is event and one is context. Okay. Now, see, in the bucket, in the bucket, in the bucket or any folder, when I place a file, it will generate a event. It will generate a event. So we are going to configure that event. When I place a put, means placing a file, I want to call this lambda function. In that event is passed to this parameter called event. So event, we are accessing bucket name. We are getting bucket name. From that event, we are getting bucket name. From that bucket, we are going to get our file name. From that file name, we are going to read data using Boto3 API. We created connection using Boto3, right? S3 dot get object. From this entire path, we are going to read a file. From that file, we are converting into human readable format content. Then that file we are converting into CSV format. Then we are appending data, CSV data. So we are writing complete processing logic here. Processing logic. Finally, this input data we are writing into output location. Instead of CSV, we are writing into JSON format. Just we are copying and writing just for showing the example. In this example, we are reading CSV file and we are converting into JSON format. And again, we are writing into S3 location under processed folder. Under processed folder thing. Okay, let me save this program. So program is generated. You want to update this modified code. What we have to do? We have to click on deploy. Yes or no? And after deploy, you want to give a access permission. See, Lambda is different service, S3 is different service. Yes or no? You want to give an access to your Lambda function to connect with S3. Then tell me, what is required? Can anyone tell me what is required? AWS IAM role. Yes or no? Yeah, we need a AWS IAM role to access S3. So how we can provide that one? See here, go to configuration and here you can see permissions. Okay. See role name. Whenever you create a Lambda function, it is created a role. This is the role name. Role name. Whenever you create a Lambda function, For every Lambda function in AWS IAM, it will create a role. Go to IAM, okay, go to IAM, then go to roles, search this role, click on this role, then add permission, attach policy. Which policy is required? S3. Search S3, S3 full access, attach this one, add permission. We are reading, we are writing. So we need a full permission. Then we attach the permission. Now our Lambda function having a capability to communicate with what? S3. Okay. How Lambda function knows event is generated? How Lambda function knows event is generated? We have to create a event, a trigger. Go to Lambda. Go to Lambda. This is my code. This is my code. You can see here, add trigger. Click on add trigger. Then, which is your source? For Lambda, which is the source? For this application, which is source? S3. S3. Yes, correct. Orders file placed in S3. So source is S3 location. So select to source. So you can give, these are different sources. For Lambda, you can give these many sources. See it. So I want to search S3 is my source. Select a source. Then select a bucket. What is our bucket name? Akkem Sreenivas Lambda. Okay. Then see here event types. Event types, you can see here, you can see multiple events, put event, post events, copy event, multiple, but I am giving all events. At this time, I am giving all events. Then I am selecting I acknowledge. Then click on add. I created S3 trigger. Now go to this location. See AWS Akkem Sreenivas Lambda. You can refresh. Currently, we have only incoming folder. Click on this one. Just place our file. Place our orders file. Place our orders file. Is it required test Lambda function? No, right? Because we created an event. No need call Lambda function manually. We created a trigger. Whenever we upload a file, Lambda function going to trigger automatically. Then it performs this processing logic automatically. You no need to do manual calling of this test. Manually calling of this test, creating test, running test, that is not required because we configured event when anyone places file in this bucket, this Lambda function automatically going to trigger. So you no need to do any manual. Then I want to know whether this is running or not. This code is ran or not. We uploaded a file. Let's scroll down below. Yeah. Go to here. You can see monitor. You can see log is going to see here. You can see CloudWatch log. See CloudWatch log means whenever you put CloudWatch log is created. And let's see, click on this CloudWatch log location. and go to CloudWatch log and verify event details. See, this is event details. So request is started. Let's go our input location and refresh our bucket. Go to Lambda. See, process is created. In this, it is generated order.json. Clear writing. We have implemented. We have implemented data processing logic using AWS Lambda S3 based data ingestion. Okay. Uh, let's start it. In this, we are going to discuss master Amazon Kinesis. As part of master Amazon Kinesis, let's start understanding what is Amazon Kinesis and features of Amazon Kinesis system. Let me explain Kinesis system. So before going to explain Kinesis, let's understand stream. Let's understand streaming. Stream means continuous flow of data type. Stream means continuous flow of data. Let's say take a log, take a uh, log file. In this log file, maybe application server, maybe web server, maybe web server, maybe database server, maybe other servers writes continuous data into this location. Yes or no? Continuously, they write data into this location. Maybe sensor data, maybe GPS data, maybe IoT data, etc. So data continuously writes. Stream means continuous flow of data. Continuous flow of data. Continuous continuous flow of data. Flow of data. So if any source generating continuous flow of data, we use streaming frameworks. We use streaming frameworks like mm, let's say here we use streaming frameworks. Streaming frameworks to read this continuous flow of data. Can anyone tell me what are different streaming frameworks available in real world? Yes, correct. There is a component. There are multiple common components in Apache. So we have Apache side, Apache having multiple components, like Apache Flume is one component, Apache Kafka is another component, Apache Storm is another component, Apache Storm is another component, and Apache Spark Streaming Spark streaming. Like this, Apache having multiple streaming components, multiple streaming components to handle with the streaming data. Similar way, AWS having specialized component, AWS having specialized component called AWS Kinesis. Kinesis is specialized components. Kinesis is specialized components for handling handling this streaming data, like this Azure having Azure streams, Azure streams, Azure streams. Similar way, GCP having PubSub, GCP having PubSub. Different technologies having different components to handle streaming data. You are saying Apache Kafka. It's not AWS. Apache Kafka you can install in AWS, Azure, GCP, anywhere. Title is Apache. Component from Apache. Okay? Yeah. So AWS having specialized component is Kinesis to deal with the streaming data. So there are having plenty of technologies having streaming technologies, streaming technologies in AWS, specialized service called AWS Kinesis to deal with streaming data. There are plenty of frameworks available in real world deal with the streaming. Not only these components team. There are plenty of tools. There are plenty of tools available in the market. Not only these, there are plenty of tools. In that, AWS AWS specialized service called Kinesis. It deals with pure streaming data. Okay, yeah. Let's start understanding Kinesis. Now let's start understanding Kinesis. So understand, right, what is Kinesis? Kinesis is a powerful AWS service designed for real-time data or streaming data. Along with, you can also do analytics, live analytics using that streaming data. Kinesis can be configured with any source like IoT devices, applications, websites, clickstreams, any streaming source. Then we can capture the data. We can write output into S3, or if you want to do any analytics, you can write analytics on the streaming data. Results also you can write into S3 or some other. Mostly how we use Kinesis is, let's say, streaming source, streaming source, streaming source. Here we are getting continuous streaming data. We configured Kinesis. We are going to configure Kinesis. We are going to configure Kinesis for streaming data. Then we are going to write it into S3. Usual requirement. Usual requirement is in this way. So we are going to write it into S3. Once data is presented in S3, then we are going to write Glue application to process this data. And then finally, we are going to write into data warehouse. These kind of scenarios we can see in real-time environment. So mostly we are going to see these kind of requirement using Kinesis. Using Kinesis, we are going to connect the different sources and we are going to write it into S3 locations. This is usual requirement. Today. So Kinesis can be used to connect different sources and can be read streaming data, can write it into target location. Okay. Now let's understand what are features. There are plenty of technologies available in the market. Just we see some components in real world. Then what are advantages of Kinesis? Why industry chooses Kinesis? First point it is. First point, Kinesis is uh, used for reading streaming data. This is common requirement. Second one, scalability. Let's say, let's say team, let's say existing architectures, existing technologies. So this is my streaming data. This is my let's see existing architecture team. Existing architecture. This is streaming source, and we created a cluster, cluster for existing architecture. That's a we created multiple missions, multiple missions to implement this one thing to read this data. Let's say you are getting huge volumes of data. If this cluster is not supporting, then you need to add missions manually. Yes or no? Add missions manually. Coming to AWS Kinesis, Kinesis, Kinesis scales, Kinesis scales automatically to handle any size of data. Kinesis scales automatically. You no need to, you no need to say, you no need to say fixed cluster like existing architecture. You no need to set up a fixed cluster like existing architecture based on the data, based on the streaming data, automatically scales to handle any amounts of streaming data. You no need to set up manually. Yeah, without a serverless, how it will scale automatically? No, right? It's a it is a serverless architecture. Next one. Next one. You can integrate you can integrate you can integrate Kinesis with different services like Lambda, S3, Redshift, EMR. So you can integrate Kinesis with different architectures, AWS services. You no need separate mechanism for integrating. You just need a role to connect Kinesis to these services to Kinesis. You need a role. You attach role to corresponding service, then that service can communicate with Kinesis. You can easily integrate with any AWS services like Lambda, S3, Redshift, EMR, Glue, etc. And next, coming to security, any AWS service, any AWS service by default get security from which service? AWS IAM. Let's say I want to access Kinesis service from other service. We need first important service is IAM. Along with IAM security, you can implement encryption, you can implement authentication to provide security to the data during uh, transform during transform and storage data. You can implement encryption and authentication with Kinesis, so that you can provide more security to the data. Along with IAM, we have encryption and authentication techniques to provide security to your data. And next one, low latency provides sub-second response times for streaming data ingestion and processing. Low latency. It will not take much time for storing streaming data and processing streaming data. It is super fast. So these are main important features in AWS Kinesis system. Okay, clear, right? Hope all of you understand what is Kinesis and key features of Kinesis. Yeah, let's continue. In this, let's continue master Amazon Kinesis. Let's continue Amazon Kinesis architecture and components. Okay, let's see. Amazon Kinesis having different components. So let's see Kinesis architecture. Let me explain. Let's say you have streaming sources where data is continuously generating, where data is continuously generating. These sources continuously generating the data. In AWS, we have Kinesis. Kinesis having different components. Kinesis streams, Kinesis analytics, Kinesis firehose, and there is one more component called Kinesis video streams. Kinesis video streams. If you want to deal with video streaming data, there is a component called video streams. Sorry, Tim. Let's discuss streaming data. Let's discuss streaming data. Let's say I am getting continuous streaming data from these sources. There is a component called Kinesis streams. You can configure this Kinesis streams for streaming source. You can configure Kinesis streams component to capture or to read data from different sources. Then I want to write analytics on that data. There is a component called Kinesis Analytics. It provides SQL kind of framework. On this data, you can write analytics. No, I want to write this data into S3, Redshift, Elasticsearch, Splunk, etc. locations. Then You can configure this Kinesis streams with Kinesis Firehose. You can configure this Kinesis streams with Kinesis Force, Kinesis Firehose. These can communicate with any of different targets, any of these different targets, and writes the data into target locations. Let's say I want to write analytics. You can write, then you can give result to Kinesis Firehose. Kinesis Firehose can talk with any of these targets and writes the data. So in Kinesis architecture, we have Kinesis streams. We can configure Kinesis streams to in sources where streaming data continuously generating. If you want analytics, you can use another command called Kinesis Analytics. If you want to store this streaming data into target sources, there is a component called Kinesis Firehose. Kinesis Firehose to connect with the targets. So these are different components in Kinesis architecture. Kinesis data streams, Kinesis Firehose, Kinesis analytics, Kinesis video streams. So you mean to say, yeah, you mean to say you want to just to stream. That's it. You do not want to write into any output source. Then this Kinesis data streams are enough. Then then this one and these things, these two are required. You just capture stream data. You do not want anything. Just configure streams. You want to store it into target. You need Kinesis data streams, Kinesis Firehose. Tell me, what is the purpose of here, Kinesis? You only tell me. Okay. Tell me, by seeing this diagram, we already discussed. Tell me, I'm just trying to help you to understand. Then tell me. Yes, correct. It is finally right into these targets. Write this streaming data into targets. This is for capturing the data. This is for writing the data into targets. Okay. Redshift is data warehouse. Data warehouse. RDS is a database. Database always having a limitation. Hmm? Yeah. Mm, you are getting streaming data. Want to find any fraud detection, or you want to find anything happen. Let's say suspicious things you want to find. You can't. You are getting GPS data from different traffic signals. Then you want to give a intimation if you find X person is in X traffic, what update that data to nearest traffic signal police. Such kind of analytics we can write using SQL. I said it uses SQL. If you remember, it here we write SQL. No need of writing programmatic implementation. See, once we write any implementation, we can push our code to virtual version control system. That is common for any programmatic implementation or any SQL query. Anything, if you are writing SQL query, if you are writing Python program, then that can be pushed into any version control system. It may be Java, it may be Python, it may be anything. In universe, if you are writing manually means you can push it into version control system. Then only we can move to corresponding environments. We never move manually from dev environment to test environments to production. That is common. Understand, if you are writing manual anything, SQL, text, programmatic implementation, that can be pushed into version control systems. That is common for every technology. Okay. Clear item? Amazon Kinesis architecture and components of Kinesis. Yeah. Yeah. Now let's start understanding Kinesis streams. Let's say this is my Kinesis data stream. Kinesis data stream. Kinesis data stream. Data stream. Let's say let's say we are configuring streaming source, streaming sources, where data is continuously coming, you can configure, or you can write producer application using any technology. Using that, this may connects to streaming source, and this will write into data, Kinesis data streams. If it is log file, you can directly configure this one, or you can use application help. Then application, we call it as producer. That producer can connect to streaming source and writes into data streaming. Okay. Now, now here a data stream divided into multiple shades. Shade 1, shade 2, shade 3. In other another streaming technology, we call it as partitions, right? Similar way, in Kinesis data stream, we have a shade. So we can create multiple shades to handle streaming data. Okay. A stream is divided into partitions called shade in Kinesis. A message like partitions in other streaming frameworks. In Kinesis, we have shades. Advantage of Kinesis data streams: message is going to store into shade, right? Message is going to store. The streaming message is going to store into shade, right? The advantage, a message we can replicate into availability zones, multiple availability zones. Let's say you are using this Kinesis in Mumbai, Mumbai region. Let's say you are implementing this Kinesis into Mumbai region. In Mumbai region, we have three availability zones, right? Let's say South Mumbai, South Mumbai, North Mumbai, North Mumbai, and East Mumbai. Then you can replicate this message to three availability zones. By default, it automatically replicates into three availability zones. Same message, same message presented here, here, here. If anything happens in entire availability zones due to earthquakes, due to natural disasters, anything happen, still we have data from other availability zones. If you want to implement this architecture in existed, you have to do lot of things, manual configurations, many data centers we will take. We have to implement manual things, but the messages are replicated automatically in three availability zones. If one entire availability zone is not available, then still we can access other availability zone. We have one more important feature, cross region. It is little costly, little costly, cross region. Let's say one replica you want to maintain in Mumbai, one replica you want to maintain UK, one replica you want to maintain US, called cross region. This is also possible. You can set up as a cross region. Entire Hyderabad, Mumbai is not available. We have data in UK, we have data in US. Such kind of cross region implementation also possible, but it is little costly. Next one. Yeah, yeah. So here always consumer for Kinesis data stream is Firehose or data analytics. Because if you see previous architecture, Kinesis architecture, Firehose can read data from data stream and writes into target location. Here consumer, we write what? Kinesis Firehose, or you can even write an application to read data from Kinesis data stream. You can write a Java or Python application to read data from this Kinesis data streams, and then you can write it into targets. Once the data written into targets, you can uh, configure uh, downstreams like Power BI or some other tools to utilize that data. And Kinesis data streams are highly available. By default, these are available in 7 days. By default, retention period is 24 hours. We can increase to 7 days. Okay, next one. Let's say message I created here. Message I created here. In other technology, once you read this message, once you read this message, then that message we cannot reread in other messaging systems. But here we can ability to reprocess, replay the same data any number of times. There is a limitation. Yeah. No. So here I updated here. One more point. Let me add the point. This is my data stream. Data stream. Let's listen carefully. Already I updated. We can directly configure to source. We can directly configure streaming source. We can directly configure, or we can use Java, Python, etc. kind of technology. You can write an application. You can write data into Kinesis data stream. Okay. Next one, consumer. Coming to consumer. I already said there is a component, Kinesis Firehose. Kinesis Firehose is a consumer. It reads Kinesis data stream data. It will write into targets. Okay. Also, we can write Java application, Python application to consume this data stream data and write into targets. Okay. Yeah. So playwright Kinesis data streams, and Kinesis message is immutability. Let's say you are writing message, streaming message from here. You cannot delete that one. Once we insert data into Kinesis, 1 minute. Kinesis messages are immutability. Once we insert message into seed, these messages manually we cannot delete. These are immutable based on the retention period, based on the data retention. It may be 24 hours, it may be specified number of days. This messages deletes from Kinesis data streams. Okay, clear, write it in Kinesis streams. Yeah, let's start in. As part of Master Amazon Kinesis, in this session, we are going to discuss Kinesis real-time streaming. Uh, Kinesis real-time streaming using Kinesis Firehose. We are going to use Kinesis Firehose. First example. In this example. Okay. Yeah. What we are going to do, we have already discussed about this Kinesis Firehose. Kinesis Firehose connects with targets like S3. Using Kinesis Firehose, we can write messages into S3 or any target. Example, in this, we are going to write messages into S3. So we are going to create a bucket. In that bucket, optionally, we are going to create a folder. In that folder, we are going to write messages in file. So this is our requirement. Then how we are going to do inputs to Firehose? In Kinesis, we have a source option called direct to put. So whenever we run this Kinesis Firehose, we can select a source as a direct put. Let's say a JSON message. Here we can pass run parameter as direct put any message, not only JSON. You can pass any message from direct put option. So there is an option called direct put. Using that direct put, we can generate a sample message. Let's say I want to generate some records, and I want to generate that records continuously until I stop. I stop. Otherwise, it will keep on generating messages and pushing that messages to Kinesis Firehose. Let's start implementing this one too. So here, let's create a let's create a bucket like this. Let's say I am creating, let's say, here, first I'm creating bucket name, um, Akkem Sreenivasa Kinesis. In that bucket, let's say, create a folder, this S3 output. Let's create a folder in this way. Let me go to S3 bucket. I am opening S3 bucket. Then in that bucket, let's first create a in S3 and create a bucket called create a bucket, and I'm giving bucket name Kim Sreenivasa hyphen Kinesis. Then uncheck this option, click on I acknowledge, and then click on create a bucket. Okay. So we have created a bucket. Let's create a folder. Let's create this folder. You can write output into this folder, or you can give direct to bucket name. Okay, optionally I'm creating a bucket. Let's create a bucket. So step 1 is completed. Now I am going to create a Kinesis Firehose. So open service called Kinesis. Open service called Kinesis in a new tab. Firehose in a new tab. Here, let's see it. So I opened Kinesis service. Here, you can see you can create a Kinesis data stream. You can create a Amazon data Firehose or other option called Amazon managed Flink. In this example, I am creating Amazon Firehose. Okay, let me select this Amazon data Firehose. Click on create Firehose stream. Yeah, here select a source. And source, I said, we are going to give messages directly using direct put. Okay, go to select here, and here I am selecting direct put, and destination I am setting S3, and S3, see, Firehose stream name, I am giving Firehose stream name. You can give any name, and let's say here I am giving real-time streaming. Real-time streaming. Okay. Now transform and convert records. If you want to give any options, you can select. So destination is this one and stream name. Then select a bucket path. So browse a bucket path, and here Akkem Sreenivasa. In this Akkem Sreenivasa, So first select a bucket. Select a bucket. Okay. After selecting bucket, see here, if you want to give any folder prefix, here you can add. We created Kinesis S3 output, right? If you want, you can add. Otherwise, it will directly go to write it into bucket. First example, I'm using bucket. Then advanced settings, later we'll discuss. So we given first one, direct put, destination and stream name, then bucket path. Then click on create a Firehose stream. We have created a Firehose stream. See here, one important point. Our Firehose going to write data into bucket. S3 is different service. Kinesis is different service. You will get error. What you have to do to resolve this error? Okay, tell me. I am writing permission. If I write permission, is it works? Okay. If I say policy, it will work. Tell me the procedure. How we can do instead of saying this one. Tell me how to do. How to do. No need. No need of any agent. If you observe here, create IAM role with this name means it is created already. This IAM role. Go to take this IAM role. Take this IAM role. Then go to IAM. Go to IAM. Search this role. Go to roles and search this role. Okay. So this role is presented here. Click on this role. Then tell me. Tell me what what we can do. Okay. I am writing S3 full access. Is it works? Tell me how to give full access. If I write this one, is it works? No, you are not understanding. Add permission, correct. Add permission, attach policy. Tell me, search S3 full policy. You're not telling steps. Add permission, then we attached permission. Then now go to our Firehose. Now let's try to create a Firehose stream. We got error because of that permission issue. Now let's create a Firehose stream. Observe. Now it is able to create. Yeah. So step one bucket is created. Correct. Yes, correct. Yeah, yeah. So now let's start this step three also completed. Now let's run Kinesis Firehose to generate a sample data. So there is an option test with demo data. You can see here test with demo data. This is the demo data. Do you want to change this demo data? You can change. So let's say they given sample demo data. Then you can click on start sending the demo data. So it is continuously sends the demo data. It is just streaming. So there is no stop until unless you click on stop sending the data. It will continuously sends the data. Go to S3 location. You can refresh this bucket. You can refresh this bucket. Here it is going to create a data. So let's click on stop sending the data. Once again, start sending the data. Stop sending the data. Then again, start sending the data. Stop sending the data. Start sending the data. Stop. You can wait for some time. You can generate multiple records. You can see, go to configuration. In configuration, you can find that permission also. Okay. This is permission we given using IAM policy. So stop sending, and you can click on start sending. You can click on stop sending. So whenever you want the data, click on start sending. If you do not want to send the data, click on stop sending. This is direct put using Firehose. We are writing messages into S3, and for that Firehose, we are sending continuous streaming data using direct put. Direct put. Okay. You want to know whether it is sending or not. You can see here it is giving monitoring. Okay. And even you can say if there is any error while sending, you can see this CloudWatch log. CloudWatch log. Here you can see complete log with error messages. If there is any delivery issue, we can see complete error messages here. And go to S3 bucket, refresh. So we created folder, but we did not give this folder. We given only this path. Let's say bucket. Go to Kinesis bucket. Let's refresh. Observing, we stopped sending the data. Let's click on start sending. Let's see, go to S3 location. You can see year is created. In that year, month is created. In that month, today's date is created. In this, you can see files. Files. Let's click on this file. Let's go back. Select this file and click on download. Go to this file. Go to this file location. Open this file. See the data. It is writing. So whatever record we mentioned here in sending, it is writing each record. Stop sending. You can go to S3 location. Go to refresh. Refresh. You can see complete data. It is keep on updating that direct put messages. So direct put we use only for practice purpose. This is generating a sample data just for testing whether Firehose is working or not. We configured Firehose with S3 location. Then we generated dummy data or sample data using direct put option in this example. Now let's continue master Amazon Kinesis. In this, let's continue next important topic in Kinesis data stream is Kinesis data streams. Short form is KDS, Kinesis Data Streams. You may have a idea of messaging systems. We create a topic, right? We create a topic, and in this topic, we get data. Yes or no? In generic or different other messaging or streaming systems. So in this topic, we are going to write data continuously. Topic. Similar way, in Kinesis, we will create a data stream. We will create a data stream. We will create data stream. In this data stream, we are going to write messages. We are going to write messages. So using any of different approaches you can use, then you can write messages into this data stream object. Later, you can configure Kinesis Firehose, Kinesis Firehose, Firehose to read this streaming data and write it into targets. Write it into targets. Okay. So a data stream can hold continuous streaming data. So a Kinesis data stream is a real-time data streaming service that allows you to ingest high throughput data from multiple sources, from multiple producers. From multiple producers, you can write continuous streaming data into this data stream. And later, we can use consumer, like if we configure Kinesis Firehose, it is a consumer to this stream. It is responsible to write that streaming data into targets. Or you can write a Java application, or you can write a Python application, or you can write a AWS Lambda application to read this data, write it into target. Okay. Let me add one more point here. Producer, and consumer, for this data streams, consumer for this data streams. Okay. Here, first we will create a data stream. First we will create a data stream with a number of sets. Then using producer, previously we seen direct put. It is going to put data directly into a Firehose. So instead of data, continuous streaming data in streaming source, for this purpose, we have one direct put option. We directly generated data into Kinesis Firehose. This is one. Next one. Here you can write Java or Python or Scale or .NET, etc. etc. AWS Lambda, AWS Lambda, AWS Lambda, or different technologies as a producer. Then you can write messages into this Kinesis Kinesis data streams. Okay, this is first important step one. Step two. Because step one is creating a data stream object. Kinesis data stream object. Step one is a creating Kinesis data stream object. Step two is writing producer applications using any of the languages, or you can use AWS Lambda to produce data. Other side, step 3, you can write consumer application like Java, Python, .NET, .NET, or AWS Lambda, etc. to consume this data and write it into targets. Write it into targets. Instead of writing these kind of applications, Kinesis people given a component. Called Kinesis Firehose. You can configure data stream. You can configure target. It will read all streams data. It will write it into target location. You can use any of the consumer technology. You can write it. You can connect with the Kinesis data stream and read the data, or AWS Kinesis people given a component called Kinesis Firehose to read this streaming data. Okay, clear, right? What is Kinesis data streams? Yeah, let's understand. We seen what is Kinesis data stream. Now let's understand components in this Kinesis data stream. First important one, a data stream with the sets. A data stream with the sets we will create. A stream we will create. It is a pipeline for continuous streaming data. In that we give a partitions like other technology. In AWS Kinesis we have a said a unit of capacity in a stream. Then producer is a application. It writes messages into this stream, and consumer is another application. It reads messages from this stream, and in this producer going to write a message, right? Each message we call it as record. Record. Every record contain a partition key, and every message contain a sequence number. Based on this sequence number, we can understand what are messages we read. Let's say sequence 1, sequence 2, sequence 3, sequence 4, and our consumer read sequence 3. Then it will continue from sequence 4. That's why every message contains one unique ID called sequence number. So these are different components of a Kinesis data stream. Let's continue master Amazon Kinesis. In this, let's continue how to implement Kinesis data streams. So here we are going to see practical example. First, let's go and open Kinesis data stream. Okay. So here let me start a Kinesis. Let's open Kinesis. Then directly see here Kinesis data stream. You can open this one, Kinesis data stream, or you can click on Kinesis and then select a data stream. Okay. So I selected Kinesis data stream. Then it opened this Kinesis data stream product. Here you can see currently there are no Kinesis data streams. You can click on create data stream and here give a Kinesis data stream name. So here I am giving Kinesis data stream name is click stream data, click stream data. You can give any name. So I am using this graphical approach, and you can also use AWS CLI. AWS CLI. You can execute these commands to create a Kinesis data streams. Okay. Now, once we give a name and select on demand, then maximum record size. I'm giving 1024 KB, means 1 MB. Each record or message size I'm giving 1 MB. Then remaining options are optional. Click on create a data stream. Create a data stream. So there is a data stream is created called create data stream. Okay. So here you can go configuration. If there is any permission is required, you can see all the configuration details here. All the configuration details here. Okay. So applications and monitoring, configuration and data viewer, data analytics, data sharing, and different options. So we just created a data stream called clickstream data. Clickstream data. In this currently we did not write any message. Now let's start producing data into uh, Kinesis data stream using Lambda. Okay, I am going to write a Lambda application. Let me create a Lambda. So here I'm writing Lambda. Let me open Lambda. So one Lambda I'm opening as a producer. Another Lambda I'm going to write as a consumer. Let me first Lambda. In this Lambda, I am creating producer application. Producer application. So I am giving name is clickstream data producer. Clickstream data producer. Okay. Let's create a function, and the function name is clickstream hyphen data producer. I'm selecting language called Python. Then here uh, create a lambda function. Then write this lambda code, and tell me what are required for this lambda function. Go to code and modify existed code and remove existed code and add this code to it. Remove this code and add this code. So in this code, what we are doing? We are doing imports, then we are writing lambda underscore handler, and before that, we are creating a connection between our lambda application with Kinesis service using Boto3. Boto3. And once we create a connection, before writing data into Kinesis data stream, I'm generating some random data. Random data means I'm generating 10 records. 10 records. Then these 10 records I am going to write into Kinesis data stream. Kinesis data stream. So this is my stream name. This is my stream name. And I am converting this data into uh, JSON dumps. And finally, I'm writing this data partition key. I'm using this user ID. Yeah. So total 10 records I generated random records with random ID. Then I I'm storing or pushing these 10 records one by one into clickstream data. Okay. Uh, Now tell me, uh, I am clicking on next step is deploying. Is there anything we need to do for this Lambda function? Can anyone tell me? Hmm. So my part is Lambda function development is completed. I completed deploy. And after clicking deploy, can I need to do any additional thing? Yeah, correct, correct. We need to attach IAM role to write messages into Kinesis data stream. Kinesis is different one and Lambda is different one. This Lambda function require IAM role. Can anyone tell me how to uh, give IAM role for Lambda? Tell me the procedure, steps, where we can find that role. Yeah, I am doing create and I am doing attach. Is it works? I want to steps. Tell me the procedure, where I can click, where I can create. Yeah, tell me where. Okay, great. Go to configuration. Correct. Permissions. Perfect. Here we can find a permission role name. Copy this role name and go to IAM. Go to IAM. Let's say search IAM service. Go to IAM service. Okay. In this IAM service, go to roles. Search this role. Click on this role and tell me how to add permission. Add permission. Attach policy. Tell me which policy is required. Are we writing in S3? Where we are writing? Yeah. Genesis. Let's say Kinesis full access. Let's search this one. Let's add this permission. Now our lambda having permission to our lambda having permission to write data. Okay. So our lambda having a permission to write data. Okay, super. Now, now we need to produce the data. We need to produce the data. So before that, producing the data, before running this one, let's create a consumer other side. Other side also, I am creating a consumer. Other side, I am creating a consumer application, Lambda application, consumer Lambda application, create a function and consumer Lambda function. Then select a programming language called Python. Then click on create function. Then copy this code. Then go to consumer. Go to consumer code. Let's modify this existed code with our consumer code. Then in this consumer, what we are doing, we created a handler function. Then see here, here we are reading records. We are reading records. Where is that connectivity? Where is connectivity with our data consumer? Can anyone tell me? Here we return function. Where is that connectivity between data stream and this consumer application? Yeah, tell me. Okay, you are saying we need to mention a stream name, but understand. If I mention a stream name, every time we have to run manually this consumer application. Yes or no? I want to consume data continuously. Then what to do? That's why I did not write that creating consumer data stream connection object and all those things. I did not write those steps, but I written direct statement by seeing this one with lambda knowledge. With lambda knowledge, tell me what is this event? Not only producer, anything event is generated. That event comes to this lambda function. How we can capture that event? Where we can configure that event? You all are forgot. Let me show you. We can create a event in this add trigger. Okay. Yeah. Yeah. Here we can select a source. Our source is data stream. So type Kinesis. Kinesis. Click on this Kinesis and stream name. What is our stream name? Click stream. Okay. And here, see, we are adding a trigger. Then we are expecting latest record only. That's why I did not run my producer application. Here in trigger option I said every latest record. Every latest record. When event is generated into clickstream, sorry, data stream, capture that event. Then click on add. See here we got error. Why? Can anyone tell me why? By seeing this error message, can anyone guess? Here clearly it is saying perfect, correct. So we got access system error. So before creating connection to data stream, consumer do not have consumer do not have Kinesis access. That's why go to consumer lambda, go to consumer, go to consumer application, go to configuration, go to permissions, and take this role, and go to roles, and search a role, and select this row, and then add permission, attach policy, search Kinesis, full access. Let's say add this permission, go to Kinesis consumer, again click on trigger, then select Kinesis, then select a data stream, click stream, then latest record, click on add. This time it will not fail. It is created successfully. And in this code, observe where we are writing that red message. Whatever message we are reading, right? That message where we are writing in a console. In a console we are writing. Okay, let's see. Go to producer. Now let's start. Go to code. So here, let's start generating message. Then how we can call this producer application? You can write uh, producer, then go to producer, go to test, then create a test, then here give a name, let's say Kinesis test, then click on save, and any random message, because message we generating using click on invoke, see validation error, unable to resolve. Let me Control Z, then click on invoke, it is invoked, so succeeded, Kinesis test is succeeded, response we are not receiving anything. Go to clickstream, go to monitor, you can see here you are going to see log, that log contain data, but I am not able to see any log here. Go to here, logs, view CloudWatch logs, then go to corresponding consumer log. See here, this is consumer log, and you can see data, user IDs. It is generated random user IDs. Clear, right? Producer is generated message and consumer consumed that message, then displayed into console. Here console is configured as a log. No, it is generated random numbers, user IDs. This I value we are adding as random number, user ID number. Random function, Python function we called. That is, you can give anything. That is not mandatory, because yeah, we are not reading that values in our program. We are generating values randomly with our code. Let's starting. In this session, we are going to discuss Master Amazon Redshift. Okay, as part of Master Amazon Redshift, in this session, we are going to discuss what is Redshift in AWS. Okay, let's start discussing what is Redshift in AWS. So first important point, AWS Redshift is a data warehouse environment in AWS Cloud. It is a data warehouse service. It is managed by AWS. And main advantage compared to other data warehouses with AWS data warehouses, it supports unlimited storage, and we can take this Redshift as a service in pay as you go basis. Pay as you go basis, and main purpose of Redshift is let's say we have different data sources. We have different data sources like file systems like CSV, JSON, XML, Avro, etc. And we have multiple different RDBMSs, and we have different NoSQL databases. Assume we have different cloud file systems, and we have different cloud data warehouses, and we may have different data storages. From all these sources, we can use data ingestion technique. We can connect these sources. We can load the data into raw layer of Redshift data warehouse. We can load this data into raw layer of Redshift data warehouse. We have different techniques like Python, PySpark, Glue, Lambda, and we can use Redshift concept to ingest data from different sources to Redshift data warehouse. Here we can store history of data. History of data. We can store what? History of data. On this history, we can implement ETL or ELT operations. We can implement ETL or ELT operations using different technologies like PySpark and any other ETL framework. And once we apply ETL operations on this data, and we can store the results temporarily into stage area. We can store results into temporary area called stage. Once we can store, we can validate data is generated as expected. Data is generated as expected. Once we confirm data is generated as expected, then you can move the data into transformer layer or target layer. Then this data become to different consumers of our Redshift like BI people, QuickSight, Power BI, Tableau, etc. are machine learning people or artificial intelligence people. These people connects this data and use this data according to their requirement. If it is BI people, they are going to prepare reports or dashboards. If it is ML and AI people, they are going to do prediction operations, feature prediction implementations on this Redshift data warehouse data. So we are going to apply ETL operations on raw data. Then we are make that data readily available for analytics. Okay. So this is our main purpose of data warehouse. A data warehouse is a place where we can store history of data. History of data. On that data, we apply ETL operations and make that history of data ready to do analytics. Analytics ready. We can convert raw data to analytic ready data using ETL technologies or data engineering technologies. Okay, clear, right? Yeah, let me explain one more screen. Yeah, let's see here. Uh, let me explain one more screen. Here, so we have different sources. We have different sources. Okay. We have different sources. Let me explain. So here, one important point today, usually how we are going to implement this one is using data ingestion techniques. We connect to sources, and we load this data into a cloud file system called AWS S3. We call it as data lake. Okay. U- usual implementation is from sources, we apply data ingestion techniques. Required, we do basic validations, and then we load the data into AWS. And from that, we implement ETL operations if required. Or we can connect this source and we can load the data into this one. Or data ingestion techniques we directly use, load the data in raw layer. First approach is using data ingestion techniques. We can load directly into Redshift raw layer or load it into S3. If it is S3, then what we are going to do? What we are going to do? Use Redshift command. We can connect to S3. Then we can load the data into this raw layer, or we can use AWS glue and we can connect this S3 and we can load the data. If any validation or any logic required to apply on three data before moving the data to Redshift, then we go to Glue or any other technology, because here data is huge volumes. If it is direct data, let's say you are moving data directly from S3 to Redshift, then you can use a simple Redshift copy command. You can move S3 data to RAW, or if it requires any checks or preliminary checks, then we use blue bit of technologies or PICE or any data processing technology to checks that preliminary checks or basic checks on S3 data. Then we move it to Redshift raw layer. Or fifth one, fifth one, we can directly apply ETL operations, ETL operations on this data, this S3 data, then result we directly load into transformer layer. These kind of implementation we can do in, we can do on source data, can persist into data warehousing. These are different kind of operations applies source data ingestion into data warehousing. Okay, multiple ways. It depends upon the architecture. Let's say, some they want to store the data into cloud file system first, because compared to data warehousing, cloud file system price is less. Cloud file system is less. On cloud file system, they may using different other techniques. They may use other modules to connect that history of data. They store that one. Or they want to store directly into data warehousing instead of maintaining two different services. They want to maintain complete history of data into one location. Then people directly go to data warehousing. S3 supports unlimited storage. Redshift supports unlimited storage. Only one thing, price is different. Redshift price compared to S3 price little higher, because it uses data warehousing techniques. Okay. Hope you understand what is AWS Redshift. Hmm. Now let's continue Amazon Redshift architecture. As part of master Amazon Redshift, they're understanding uh, different concept. Let's start understanding Amazon Redshift architecture. So first, let me start with low level. Let's say this is my Amazon Redshift cluster. This is my Amazon Redshift cluster. In Amazon Redshift cluster, we have we have leader node, leader node, and we have compute node. We have compute node. We have leader node and compute node. Leader nodes, you can take any number, any number depends upon your requirement. You can specify any number, okay? But here we select odd numbers like 1, 3, 5, 7, like that you will select it. Next one, in compute node, in compute node, nowadays we are finding a compute node with good resource like uh, 16 GB RAM, 32 GB RAM, 64 GB RAM, 8 core processor, 16 core processor, and 32 core processor. If you go with the cloud, say normal laptop and desktop, if you go with the cloud, you are getting very, very, very good resources. So here, compute node utilizes compute node utilizes that resources. You can divide a node into node slice. You can divide a node into node slice. Node slice. Okay. Like this, you can create any number of compute nodes. Any number of compute nodes. And these compute nodes you can scale depends upon your requirement. There is no limit. You can add any number of compute nodes. Compute nodes holds the data and process the data. Holds the data and process the data. Leader node takes request from clients. Leader node request from clients. Now let's understand how outside applications can communicate with AWS Redshift. AWS Redshift supports two kinds of drivers. One is JDBC and other one is ODBC. It supports JDBC and ODBC. Let's say team, I want to directly work with Redshift. Redshift provides nice user interface called query editor. Query editor. Using this query editor, using this query editor, using this query editor, you can you can write SQL. You can write SQL. And one more important point here, Tim. One more important point. Amazon Redshift, Amazon Redshift implemented based on similar style of PostgreSQL. You may know Postgres is you may know Postgres is one of the most popular RDBMS database. It supports what? SQL. So to communicate with the PostgreSQL, we use SQL, but little syntax wise, database to database, little syntax wise. MySQL, Oracle, PostgreSQL, Microsoft SQL Server, little, not complete. All these RDBMS supports SQL, but syntax little different. Similar way, our uh, Amazon Redshift implemented similar style of PostgreSQL. So we can use PostgreSQL syntax style of SQL to communicate with Redshift. So Amazon Redshift provides query editor where we can write SQLs directly to communicate with Redshift. Or you can use any client like DBever. You can create a connection between Redshift, then you can write the queries. This is other approach. This is other approach to work with Redshift. Next one thing. Let's say you written Java application or .NET application or Python application or PySpark application or AWS Glue application or Azure data engineering application or GCP data engineering application. All these applications backend is Redshift Azure. Then Redshift providing JDBC and ODBC drivers through your application. You can communicate with Redshift. All your requests are transferred to leader node. Leader node finds worker or compute node, then assign your task to compute node. AWS Redshift is a distributed data parallel processing engine, and it can process your data very faster compared to existing data warehousing technologies. It supports unlimited storage. It supports distributed and processing. It uses dynamic resources of your compute nodes, and it will use resources capabilities, and it process your data very, very faster. In architecture, there are two important components, leader node and commit node. Leader node is responsible to take the request from client applications, then uh, send request to corresponding compute nodes. You can take any number of compute nodes, depends upon your size in your Redshift cluster. Okay. Mm. Now let's start setting up your Amazon Redshift environment. Okay. Let's start log in AWS Cloud. I already logged into AWS Cloud. Let's navigate Redshift. You can see recently visited. You may see Redshift if you already used, or you can navigate by searching in search bar, type Redshift, then open in new tab. Here you can see a Redshift available in a free tier. Try Redshift serverless free trial. Okay, let's click try Redshift server free trial. So here you have use default settings and use custom settings. I'm using default settings for my practice purpose. I need a Redshift cluster. Okay. I'm using the use default settings. Then here we can see two important parts. One is namespace, one is namespace, and other one is work group. So in Redshift, while setuping Redshift, first we are going to use namespace. Under namespace, under namespace, we are going to create work group. We are going to create work group. Okay. So first giving, I am giving, I am giving namespace. First one, namespace. See here, namespace and default namespace is, it is giving different default names. If you do not want default namespace, if you do not want these default namespaces, click on custom settings, then change this default namespace to your required namespace. Let's say I want Akkem Sreenivasa hyphen namespace. Akkem Sreenivasa hyphen namespace. Database name is a dev, and I want to custom admin user and details. Username is admin. Then here, manage admin credentials. See here, generate password or manually add the password. I am adding manual password. Manual password. Okay. Let's say this is, I'm giving India 123 123 123. Just for while connecting, I am going to use same details. Here, I am roles. I am roles. Later, I am going to create a I am. If you want to create I am role, you can create, or later you can create and add. Next one tip. Here, work group tip. Work group name I am giving him Sreenivasa, hyphen work group. Then see capacity. I am taking default capacity and remaining options default, and virtual private network default. Then remaining options are default, and click on save configuration. Click on save configuration. It will take a few seconds of time. Let's wait to complete all these steps for setting your AWS Redshift serverless architecture. Okay, let's wait a few seconds. You can observe here, you can see it is doing configuration, setting and configuration. Let's wait a few seconds to complete this process. Yeah. Process is completed. Let's click on continue. Okay, let's observe here. Let's observe. It is processing. Here. Your uh, dashboard, serverless dashboard. You can see namespace configuration. You can see this Akkem Sreenivas hyphen namespace. You can click on work group. You can see work group name Akkem Sreenivas hyphen work group. Now we can confirm. Now we can confirm. Yes, Amazon Redshift is configured successfully. So we set up Amazon Redshift environment. Okay, clear writing? Yeah. Now let's start understanding how to connect Amazon Redshift, or how to work with Redshift. So in AWS Cloud, we may have 200 plus services. We may have 200 plus services. In that, Amazon Redshift is a data warehousing service. Amazon Redshift is a data warehousing service, and it is a serverless. It is a serverless. What is serverless team? You no need to specify, no need to create manual missions for installing Redshift software. Dynamically, based on your, it is going to create multiple compute nodes. So it will store unlimited data based on your data size. It will increase the sources. Next point. So this is, we already set up Redshift environment, or we have already configured Redshift environment. Then AWS Redshift provide a query editor to connect to Redshift. Let me show Redshift. Okay. Yeah. Let me go. Once we set up a Redshift server, you can see Redshift dashboard. In Redshift dashboard, you can see query editor. Click on query editor. Go to query editor. In query editor, you can see here. You can see serverless Akkem Sreenivas work group. Expand this one. It will ask password. How we are going to connect this Redshift server? Using database username and password, or did you create any key value pair in secrets manager or federated user? It how use database user and password. Database name is dev. What is username? Admin. And password I used is India 123 123 123. And later I am going to change, just for practice purpose. I created with the password. Always recommended create your own password. Don't use common password. Then click on create a connection. So now it is successfully connected. You can see here, expand native databases. See this database, dev underscore database. You may see sales underscore sample data underscore dev. This I already created with the previous projects. That's why I am seeing this one. So this is sample. So two databases are created. One is dev and another one is sample underscore data underscore dev. So it is contains some schemas. These are also public schema. In dev, you can see public schema. In the public schema, you can see tables. Right now, there are no tables. There are no views. There are no functions. There are no stored functions. So now we are able to connect Redshift using query editor. Similar way of query editor, we can use different clients. In outside, we may see popular database clients. One of the popular database client is DB. So you can use DBever similar to query editor. Query editor is within the Redshift environment. Once I create Redshift, I do not want to open AWS Management Console. I do not want to go to Redshift environment every time. Instead, I want a client software in my mission. Then I want to connect it. There is a most popular DBever. Like DBever, you can see plenty of software which supports JDBC, ODBC. whatever RDBMS supports, JDBC, ODBC, you can use that popular database client to software, and you can create a connection between Redshift with your client to software. Then you can happily write SQL queries. Here also, you can happily write SQL queries. Other approach is programmatic, like Java, Python, Spark, .NET, AWS data engineering, Azure data engineering, SQL data engineering, anything. Let's say BI tools like Power BI, Tableau, ClickView, they can also use JDBC or ODBC to connect our Redshift. So there are multiple ways to connect Redshift. One way is using query editor. Other way is either JDBC or ODBC. Any client which supports JDBC or ODBC can connect with Redshift. Right? Yeah. Let's begin. In this session, we are going to see creating database, creating schema in Amazon Redshift, and loading data and run SQL queries. Loading data and run SQL queries. Unloading data, we are going to see after loading data and running. Okay. First, let's start creating database and loading the data from S3 bucket. Okay. So let me create a database and create a schema. Let's go Redshift. Let's go Amazon Redshift. Sorry. Here, let's write a query. So here city. Here I'm writing queries. Create a database, sales data. You can select a query. You can click and run, or you can execute. Uh, you can execute. Control Enter. Next one. Next one. Use sales underscore data. Switch from this one, or you can go here. You can refresh this one. You can see under this work group, you can see three databases. Just now we created sales underscore data. In this sales underscore data, a public schema is created. Okay. So you no need to do schema creation manually. Once we create a connection, then it is created this one. Let's click on edit connection. See, we use database name dev. Instead, you can say sales underscore data. You can change with different database name. Sorry, different database name. Then India 123 123 123. Then click on save. So now which database is pointing? Default database sales underscore data. Now let's execute creating analytical schema. Control Enter. So it is executed. Go to this one, refresh. Go to your database, and then you can see databases, sales underscore data. Here you can see public schema and dev. You can see analytics is created, but we did not specify any. By default, you can see here, it is selected. If you want a different one, then you can use sales underscore data, then it is going to connect to that one. 1 minute. Let me refresh and check. Yes, I hit a refresh. Now I am able to see sales underscore data. Then if you execute this schema, control enter, now it is going to create a schema under sales underscore data. See here, sales underscore data. You can see two schemas. One is a public schema, as well as you are going to see new schema called analytics. Okay, analytics. Next one, I want to create a table. I want to load the data. I want to create a label. I want to load the data. Let me first explain the scenarios, then later we will implement this one thing. First point, this is my Redshift. This is my Redshift. Okay. Under AWS, we have Redshift data warehouse. Redshift data warehouse. Redshift data warehouse. Okay. Data warehouse. Okay. So this is AWS service. Next, we have another AWS service. Let's say storage service called S3. Another storage service called S3. S3. It is a storage service. Usually, how applications build is different applications, they are going to write data into S3 location, S3 location. Data we are getting into S3 location. Using Redshift copy command. Redshift copy command. We can copy this data. You no need any programmatic approach. You can use copy command. You can directly copy the data into Redshift tables. This is Redshift copy command. There are other approaches using different service called Glue, PySpark, or different approaches, different data engineering techniques we use, and we load the data into Redshift tables. This is simple, easy. No need to use complex programming. You can use simple copy command to connect source and write into target Redshift table. If anything required to validate preliminary tests, basics, etc., then you can go with a programmatic approach. If you do not require any programmatic approach, you want to as it is data in Redshift environment, best way is copying data using copy command. It won't take much time. Redshift will take care to source S3 table and writes in Redshift data environment. Usually, if we have huge volumes of data, so we can use these kind of approaches. If no validation checks are required, Then use copy command, copy the data into table. If any preliminary checks are required, do that using or PySpark, do that check and write it into Redshift data warehouse table. Okay, this is called load data. Loading data into S3 from S3 to Redshift table. Sometimes client is feeling that it is costly. It is costly, and you do not want to continue with Redshift. You do not want to continue with Redshift. One thing, one thing. You feel costly. Then you do not want to continue with Redshift. Then we can unload the data into S3. Unload the data into S3. This is one purpose. Second purpose. Let's say my client is good, big client like a banking, healthcare client. What existing applications doing? Existed applications they are using JDBC or ODBC. They are directly loading data into Redshift. My client want to maintain one more data set in S3 location. Then you can load data from Redshift to S3. You want to maintain two copies, one at data warehousing, another copy you want to maintain in S3. Mostly, first scenarios they go with unloading, and second scenario is also possible when you want to maintain multiple copies of data in different services. So loading and unloading happen multiple times in Redshift environment. You may is insert query also works? Yes, we never go with insert comes in warehousing. Small data we never go for data warehousing. It is we do with the databases, not with the data warehouses. Writing single, inserting one record, two records, five records, 10 records, such kind of activities we never do in databases. It is possible, we never do. Small data never go with data warehouses. We never do insert operations. We can do, but it never recommended. Okay. Yeah. Let's continue master Amazon Redshift tip. In this session, let's discuss how to load data from S3 to Amazon Redshift table and then write SQL queries on top of tables. Okay. So we already created database sales underscore data and we created a schema called analytics. So this is my sales. Okay. In that we created analytics schema. So this is analytics schema. In this currently there are no tables. There are no tables. Okay. Now let's start loading data from AWS S3 to Redshift table. For this one, for this one, we are going to see uh, create S3 bucket and load the file. In our case, we are loading the data. Usually, uh, S3 contain data, and as a Redshift developer, we are responsible to load the data into Redshift tables. Okay. Yeah. Let me open AWS Management Console. I already logged into AWS Cloud. I'm opening S3 in a new tab. I am opening S3 in a new tab. Okay. In this, I am creating a bucket. Bucket name is Akkem Sreenivas hyphen Redshift. Okay. Then uncheck this box and check I acknowledge. Then click on create a bucket. Click on create a bucket. Okay. And then go to Akkem Sreenivas Redshift bucket. Here, see, I am going to create a folder called sales. Let me create a folder sales. In this sales folder, I am going to load sales.csv file. Let me open datasets location, C drive, under datasets, under AWS Redshift. I have sales.csv. I am uploading this sales.csv in this location. Let me upload this file and click on upload and click on close. Click on close. Now let's continue Redshift part. So see, we have created a bucket and loaded file into S3 location. Then create a table in Redshift. So in Redshift, I am creating uh, table, create sales table. Let's create a sales table here. Go to Redshift query editor, then create a table, select this query, control enter. So we created a table successfully. Now I want to load the data. See, very important point here is we created a bucket with this name. Then I created a table. But S3 is different to service. Redshift is different to service. Then how one service can communicate with the other service? Using IAM. So we need to create a IAM role. Let's say step 3. Okay. Create a IAM role. To give an access. So go to IAM service. Let me open IAM service. I'm opening in a new tab. So this is my IAM service. In this IAM, I am creating a role. Let's create a role. Create a role. So it is allow AWS services to communicate with other AWS services. Okay, here use cases Redshift. Redshift require S3 access. So here Redshift customizable Redshift. Allow Redshift cluster to call AWS services on behalf of you, or allow Redshift cluster to call AWS services on behalf of you. So you can select anyone. Let's say I'm selecting first one. Click on next button. Here I am assigning S3 full access. I am assigning this policy. I am giving name is uh, Redshift hyphen role. Redshift hyphen role. Then click on create a role. Okay. Go to that role, Redshift hyphen role. Here you can see ARN. This is ARN. Copy this ARN. Copy this ARN. Okay. Now load data from S3 to load data from S3 to Amazon table. Here use this IAM ARN. Service role, Amazon Redshift to commands access role. 1 minute. Yeah. Remember one more important point today. One we can create role and other one while setuping uh, Amazon Redshift, a role is created. This is service role. AWS service role for Redshift. You can see this role is created. For this role, for this, you can add a permission. You can see policies. We have only one policy, Redshift to linked service policy. So only one policy is attached. Let's take this one, ARN, and let's use this ARN. And let's use this ARN inside this one. Let's try. Um, we created IAM role. We created IAM role. Let's take this ARN. Let's take this ARN. Okay. And use this ARN. Use ARN and remove spaces. Remove spaces. Okay. And then our bucket name. Take a bucket name. So go to S3 location. And this is our copy S3 URI. And then enter this S3 URI of until your folder. Let's enter this one. If there is any space, remove that spaces. Remove that spaces. And then I'm using copy command. Under sales data, there is analytic schema. In that there is a table called sales. Sales. From this file, load this file data into this table and use this IAM rule. Use this IAM rule to access S3, and my file is a CSV file, and delimiter of this file is a comma, and it contains a header, ignore header, and region is AP-south-1. But my region here, my region, if you see, I used different region. See, United States, North Virginia, US hyphen, East hyphen 1. US hyphen, US hyphen, East hyphen 1. East hyphen 1. Take this command, take this command and execute this command in Redshift query editor. Okay, let's select this entire command, control enter. So error cannot copy into non-existing table cells. We created a cells. We created a cells. Okay, let's refresh this one and check default database. So here under dev, under public, you can see there are no tables. Under sales, under public, table is created. Here we didn't mention, while creating table, we did not mention schema name. That's why it is created under public. Public. Okay. Let's execute this command once again. Take this one and then control enter. See, here error is unauthorized exception, error type, message the requested role is not associated to cluster. We created, but that is not associated with the cluster. Then go to Redshift, okay. While creating cluster, you can see role is created. Let me show cluster role. So this is our namespace. In this you can see work group and click on this work group. You can see here data access. Here you can see VPC, and then you're going to see a role. Let's check where role is created. JDBC URL, ODBC URL, and work group ARN. Work group ARN. And go to serverless Redshift, and here select namespace, and check here any role. So this is namespace name, namespace ID, namespace ERN, and then data backup. Click on database and check security and encryption. And here, see, we did not create IAM role. Remember, we have an option while setuping create IAM role, but we did not create at that time. If it is not created, create a IAM role, manage IAM role, and here create IAM role and full access, any S3 bucket, okay, create IAM role as a default, So this is save changes. Now you can see this IAM role is associated with our cluster. Take this IAM role and use this IAM role. Use this IAM role. IAM role ARN. Check any spaces. No. Here we have space. Okay. Okay. Let's take this one and let's execute this query. Let's execute this query. And here schema name is public. Take this command, control enter. No, it is started executing and loading data into our table. Yeah. See, load into table, sales completed successfully. 10 records are loaded successfully. Clear writing? How to load data from AWS S3 to AWS Redshift table. Now let's see how to run SQL queries on AWS Redshift tables. I created multiple examples. So let's see. We have created table. We have created table. Okay, this is my sales table, and I copied data from S3 location to sales table. Now I am writing query strip. Now I am writing query. Query one. So remember team, if you remember, I said uh, AWS Redshift implemented similar to PostgreSQL or based on PostgreSQL. It supports SQL queries and see SQL queries. Okay, same SQL queries. Let's see. This is my sales table. Sales table. I want sales date and some quantity into price as a total and group by sales date, order by sales date. Select this query, control enter. You can see sales date wise sum. So and so date, this is total sales. So date wise and date also we did group by and order by. So order by default is ascending order. Okay. Next I'm writing another query. I want top three customers by total spend. So customer ID, sum of quantity into price as a total spend from sales table, group by customer ID. So for each customer, it calculates this sum of total spend, then and order by this total spend. Means we get high salaries because descending order. If it is ascending order, low to high. And because of this order by descending order, we get top salaries first, followed by lower, and we said limit to 3. We get top 3 spend. Let's select this one, control enter. See, these are three clients spend more money. Next query is query 3, products with the top 3 highest sales. Product wise sales. Same as customer. Here we are using product ID as a select query, and group by also we are using product ID. Total quantity order by descending order. Let me select this query, control enter. Okay, once we create a table, once we load the data, we can write SQL query. It supports SQL queries. Yeah. Let's continue master Amazon Redshift, and let's continue how to unload data from Amazon Redshift to Amazon S3. Let's say, let's say Redshift contain data, data. Redshift contain history of data. Okay. My client want to maintain one more copy of this data into S3. One more copy into S3. This is one reason. Second reason, my client do not want to continue Redshift. Then he want to maintain here. My client want to make a backup of this data in one copy into S3. Multiple reasons. Maybe client want to unload data from Amazon Redshift to S3. So to perform unload activity, we have a command called load. To load, we have copy command. Unload, we have unload command. Okay. In unload command, we will write a query. We will write a select query. This select query return whatever conditions you write. Based on that, it will return results. The results we are going to write it into S3 location. And we have to use IAM role for communicating Redshift to S3. And we have to specify what format you want to and what delimiter you want to use. If you want to header, you can specify which region you want to load. Okay. Yeah, let me first let's continue it. So first to create path output path. So unload output. I'm creating one folder called unload output. Go to S3 location in our bucket. I'm creating one folder. Folder name unload output. Create a folder. Okay, this is my folder. Copy S3 URL. This is my folder path. Then here I'm executing this command, unload command. Observe in this S3 location, let's remove spaces and take this loading command. Sorry, this rule ERN and add this ERN. Okay, then uh, copy this command. Before that, change this region US hyphen east hyphen 1. Let me copy this command. Go to Redshift and write this query. So select this entire command, control enter. So unload is successful with 10 records. Go to S3 location, verify the data. So verify whether data is unloaded or not. Okay, let's go to S3 location and refresh this one. You can see sales underscore 00, and in this you can click on download. You can go to file and you can open this file. You can see data is loaded into S3 location. Okay, clear writing.